Today we're going to demonstrate how to deploy a virtual machine as a container in a Diamante Kubernetes cluster. One of the biggest challenges for a company is to maintain their legacy virtual machine applications when transitioning to containers. At Diamante, we revolutionize VM deployment as a container and VM management made easy with our Diamante Ultima Accelerator and Ultima Enterprise platform. We've already logged in to a Diamante Kubernetes cluster running on the Ultima Accelerator platform. Ultima Accelerator is Diamante's on-prem solution. Once you log into the Kubernetes cluster, you are presented with the dashboard view. On the left side, click on Advanced Settings and then Cluster. In the center panel, click on Features and look to make sure that KubeVirt is enabled. KubeVirt is essential for the VMs to be deployed as containers in the cluster. Once KubeVirt is enabled, the nodes need to be updated, so click Update Nodes. Here below on our demo system, we can see KubeVirt is running on 3 nodes, but you can deploy on any number of nodes that work for you. Click the Save button. After this, on the left side panel, click on Applications. Once there, click below on Virtual Machines. On the Virtual Machine landing page, you see all the existing virtual machines that are up and running in the cluster. Right now, you can see 2 virtual machines that are up and running, CentOS and Windows Virtual Machine. To create a new virtual machine in the cluster, click Create Virtual Machine. There are a number of choices that are available. The first is the VM name, which we'll call Windows 1, and we'll choose the default namespace. We have an existing node called SolServe 11, so we'll choose that one. And we need to specify the resources, CPU and memory, for this particular virtual machine. Let's choose a 10-core CPU and 10 gigabytes of memory. Let's also create a new OS disk, so choose Create PVC. We need to specify the image path where the VM is. For the purposes of this demonstration, we've preloaded this Windows VM image onto one of the nodes in the cluster, the SolServe 11 node. So we specify this path as the image path. We also need to give the PVC a name and choose the storage class. You can choose Best Effort, Medium, or High. Let's choose High and set the OS disk volume size. Usually the OS disk should be on the larger side, so let's set it to 30 gigabytes. The next option is the data disk. You can choose an existing PVC or create a new PVC. Let's choose the option to create a new PVC for the data disk and give the new PVC a name and storage class like before. In this case, High. The data disk can be of a smaller size, so let's set it to 5 gigabytes. Click the Create button. You can see that the VM creation has been successfully initiated. On this line, you can see the memory and the CPU core count, as well as the PVCs. It will take a few seconds to create the VM. Meanwhile, click on Pods on the left side, and we can see the pods getting created using the containerized data importer, which is creating the VMs. Click Virtual Machines again on the left, and we can see that the state of our new virtual machine is stopped. The Diamante platform provides not only for deploying the VM, but for VM management as well. By clicking on the Edit icon and bringing forward the VM JSON file, you can manually edit the parameters and then redeploy. You can also access the VM terminal by clicking on the Open Terminal icon. Start and stop the VM from here. And you can delete the VM from here as well. Let's start the VM. Click Start Virtual Machine. Now you can see the status of the VM, which is getting scheduled, as well as the primary IP assigned to this particular VM. The state has changed to running. This is how Diamante enables users to deploy their VMs as containers in our Kubernetes platform. Thank you for watching.